So today we're going to talk about right triangles. Have you guys heard the phrase right triangles before? Do you know what a right triangle is? I had one person shake their head, everybody else no. Abby, what is a right triangle?
There's a triangle where all sides are even.
No.
Wait, no, sorry. It's a triangle where it has a 90 degree.
A triangle where it has a 90 degrees. So, you guys know what a 90 degrees is? Like the corners in the room are all at 90 degrees, right? So, a triangle that has a corner at 90 degrees. Now, if you see a little box in the corner of a triangle, that means that's the 90 degree corner. So that's what a right angle triangle is. It has a 90 degree angle. Okay? Then we can label some parts on this triangle, right? The side that is directly across from that 90 degrees. So if I draw a little arrow here, and this is the longest side of the triangle. It's always going to be the longest side of the triangle, right? This is called the hypotenuse. Okay, so the longest side is called hypotenuse. Okay. Now the other two sides, we consider them to be similar, right? They don't have a unique name. They're both called the legs of the triangle. All right. So these other two sides are called legs, and these ones are the ones that are attached to that 90 degree corner. So the most important one is the hypotenuse. That's the longest one across from the 90 degrees. Okay. So there was this guy named Pythagoras, and he noticed a relationship between the legs of the triangle and the hypotenuse. And this guy was a Greek philosopher and a mathematician. And I sort of talked about this last day. And this guy, when he discovered this, he was so happy that he sacrificed, or I'm not sure if he sacrificed or he was willing to sacrifice an ox for his discovery. Right? He was so excited about this. So what he noticed is, hey, if you were to draw a square off of each of the legs, so create a square off this leg and take a square off this leg, then draw a square off of the hypotenuse. Okay. And you calculate the area of the square off the legs, it always equaled the area of the square off the hypotenuse for every single right triangle. Right?
So the length of the legs is like the length of the hypotenuse or whatever?
Well, we'll get there. It's not quite there. You're getting there, right? So this gave us a relationship to be able to find different sides of the triangle. Calculate it. So you have this side and this side. How do you figure that? So and also now you can do math for finding pitches of roof, distance between things. Very useful. Right? Now it's hard to imagine. So what I did is I found this demonstration on YouTube here. So what we have here is a right angle triangle, and we have drawn squares off of, or they created squares off of each of the legs, and you have a square off of the hypotenuse. And each one of these is filled with water that is dyed. Yes, Alana?
And that's what that is on the wall.
Yeah, similar, yeah. So if this theory is correct, remember area is the amount of space an object takes up. So the amount of space that this takes up and this takes up is equal to the amount of space over here. So if we take all the water from here and all the water from here, we dump it in here, it should be a perfect fit. So what we have here is this on a lazy Susan, and she takes it and you can rotate it, and you'll see that, in fact, it is true. Right?
What?
Isn't that amazing? So you take it back.
One seemed to have more than the other in it.
Yeah. Oh, the two side squares aren't the same,
Oh.
but the whole thing is that the squares off the legs
That's weird.
area adds up to be this area, right? And because we know that relationship, we can now calculate the different sides of the triangle. Oh, I don't need any more of that.
Yes, we do.
No, we don't. Oh,
We need to see a video of some.
some egg cooking there. Okay. So, if I told you, let's do a little, I didn't give you numbers here. So let's say this is 12 units in length right here, and we'll zoom in. We'll say this one is, oh no, sorry, not 12. Let's do 13 for this one. 12 here. And 5 for this one. Okay. Let's calculate the area of each of these squares and see if they add up to the area off the biggest side. All right. So area of a square is your side times your side. So if we do area of A, that would be our red box there. So that would be 5 squared, or 5 times 5, right? Which is equal to 25. There you go. Area of our blue square, area of B, is 12 squared, or 12 times 12, which is 144. Okay. Then area of C would be 13 times, 13 squared, which is the same thing as saying 13 times 13. And that one, I think it's 169, but I'll confirm. 13 squared is 169. All right? Was that fine? I did that a little fast. Calculating the area of a square should be not too hard. So, according to Pythagoras, if we added these two squares together, it should hopefully equal the third one. So if we go 25 plus 144, and it equals, what does it equal? So we go 25 plus 144
Equals 169.
equals 169. Okay? Now, so if this is true, this means we have a right triangle. Okay, remember, right triangles are just a special kind of triangle. You can have other kind of triangles where maybe they don't meet at 90 degrees, right? And in those situations, these squares would not add up to 169, or would not add up to the third one, all right? So this is actually a way to prove if something is square, right? Which comes in handy. When I was building my house, I didn't technically build it myself. I hired contractors and I hired framers and stuff like that. And we were building it, and I checked all the corners of my house to make sure they're square, right? Because when you start shopping around for houses, and if you see some houses are a little more shoddy made, right? If your walls aren't square, when you start laying tiles and hardwood flooring down, you'll notice that if it's not square, all of a sudden you'll have a strip of tiles or laminate flooring that sort of goes like this towards the end. and the rest of it's like this. Oh, it all of a sudden started getting bigger, right? It doesn't look nice, right? Because it's not square. It starts getting wider or narrower, right? You really see that with tiles, and you really see that with laminate flooring, and a lot of people hide the fact that something's not square is by carpeting it. If the carpet doesn't have a design, you can't really tell if it's not square, right? But when you do everything with like hard surfaces, it shows up so much, right? So when I was building my house, I checked all the corners, and I go to the framer. There was 2 corners that were off in my house. I'm like, hey man, you got to fix these walls. He's like, what? Why? He goes, oh, they're not square. He's like, oh, they're fine. So he goes and he pulls out, there's something called like a framing square. And all it is like a small dinky little triangle like this. And he puts it in the corner. He goes, see, sir, if it's in there perfect, it's square, right? I'm like, it's not square, buddy, right? So small things don't share the error as much. If you put a bigger triangle in there, you can see the difference quite a bit. So I'm like, so if you know some if you know some math, you can just pace it out with your feet. You go, okay, if this is 3 feet in this direction, 4 feet in this direction, the point between here and here should be 5. And we'll talk about that a little bit more along. And that proves it if something is square.
So
right?
did you get your corners of your house fixed?
Everything, they fixed the one corner, the other corner they couldn't fix because the error they made is when they poured the foundation, and even though the foundation wall is quite thick, there wasn't enough room on the thickness to shift that wall enough to make it straight. So I have one. It was fine. That one wall was only like 4 feet in length. Still, it does irk me a little bit. All right. Okay. So, off from my my little tangent here. All right. So, in a right triangle, we have sides A and B, and the side C, which is the hypotenuse, and this is the longest side. Right? And the formula that we have is we add up the squares of the short sides and it equals the square of the long side. Okay? And that's Pythagorean's theorem. Alright? Right? So let's do a question here.
Oh, b squared, a squared plus b squared. I finally understand.
Equals c squared, right? So here, I'm going to fill in some numbers. I'm going to tell you that the area of this square is 16 centimeters squared. Not the side, but the area. See, if you see a unit and it has a little square here, that tells you the area, right? And I'm going to tell you that this one is 4 centimeters squared. My question to you is, what is the area of this unknown square? Right? So we have a squared plus b squared is equal to c squared. Right? Now, I told you not the value of a, but I told you the value of a squared. I said the box off of a is 4 centimeters. So the value here is 4.
4,000.
No, you didn't do it correctly.
I got 20.
All right, it should be 20. The value of b squared
Impossible.
is 16.
Never mind.
If we add this together, is 20.
Oh, okay, never mind.
Alright.
I was like 4 centimeters.
So this is 20 centimeters squared. Now, another question I want to do is, suppose that I didn't give you the two small boxes. What if I gave you the size of the big box and one of the smaller boxes? what would the other box be? How would you do that? Yes, Lachlan.
You would go under, or you would just subtract 36 from 81.
36 from 81. Yeah, you subtract it. Right? The two small ones add up to make the big one. So the big one minus the small one equals the other one. So to write that as a formula is c squared minus b squared is equal to a squared. Big one minus small one is equal to the other small one. Right? So what does that equal? Oh, in this case, sorry, I should have used a squared because that's the box I gave you, and b squared there.
That's
77?
Yeah.
Huh?
Yes, that's 45. That sounds like a more reasonable number. You can check it on a calculator here,
Oh wait, 52.
right? So you go 81 minus 36 is 45. Okay?
Oh yeah, 45. I typed it in there.
Okay. Okay. So next question here is, suppose we have a right triangle. So I'm going to draw a right triangle. So I'm going to draw a triangle like this. Put a 90 degrees on it. It has a leg of 4 centimeters, a leg that is 12 centimeters. What is the missing hypotenuse? Okay. So my question to you is, on this diagram, first off, where is the hypotenuse? Yes.
The longest part, so the part that is like opposite the 90 degrees.
The longest part, the one opposite from the 90 degrees. So this is our hypotenuse. I'm going to put my question mark there. Okay. And that's the side we want to find. Or maybe we can label it with a C because we normally label it with a C. Okay. Now the other sides don't really matter if we mix up the numbers. Okay. So it says one leg is 4 centimeters. The other one's 12. Right. So I'll make the shorter one on here 4 and the longer one on 12. If you diagram looks slightly different, turn the numbers around. Yes.
16.
Right. Now it's not 16. Right? So I gave you how long this side is. I didn't tell you what the area of these squares are. All right? So what is the area off of the first one is 4 squared. And then we add the area off the other box. Okay?
28.
Right? So we have 16 plus 144. Okay. So 16 plus 140
210.
is 210. Is that right?
No, I got 160. I got
160.
160.
Oh,
All right. Okay.
somebody shoot.
Okay. So that tells us. Does that tell us how long the hypotenuse is?
Yeah.
No. That tells us that the box off of this is 160 centimeters squared. It doesn't tell us how long the hypotenuse is. Okay? So our hypotenuse, so this tells us c squared is equal to 160. Okay? We know the hypotenuse is c. How do we find out the value of c? Right? This is c squared. Yes?
We don't add A and B, do we?
We did. I added a squared. This is a squared and we added b squared, right? We added a squared plus b squared, and it equaled c squared, right? But the question is not how big is the area of the box, it's asking how long that is. So remember last day, if we wanted, where did we go? Where did we talk? I think we talked about it right about here, sort of, right? If, and we talked it over here, right? What we want is this number here. This is c squared is equal to r169, right? What is that base there? The way we did it last day is we took the square root, right?
So it'd be
So
13.
yeah, so we got to take the square root of this to find out the value of c. All right, so we got to go back to here. So c is equal to the square root of 160. Sorry, not 169. 160.
Is
So we go
112.6.
square root of 160 is 12.6, and it's okay to have a decimal, right? So this is 12.6 centimeters. Is that okay? That's the hardest part. So is the question, for most of the questions of today's homework, is I'm going to be asking you for what the box is, so you don't have to take the square root. And tomorrow's lessons we'll be starting to take the square roots. Right? So let's just, should we do this one? No, let's skip this one and go to the one on the last page here. All right. So the side lengths of a triangle is 5, 6, and 8 centimeters long. Determine if this triangle is a right triangle and explain. So we have a triangle, okay? The longest side is 8, and the two other sides are 5 and 6. The question is it a right triangle? Do the two shorter sides meet at 90 degrees? Okay?
Wait, what do you mean? Do they meet at 90 degrees?
That's what defines a right triangle. Is the two legs have to meet at 90 degrees. Okay? And we can prove this. It is a right triangle if and only if a squared plus b squared is equal to c squared. Okay? This is our longest side. We can just tell from the number, right? So that is going to be our c squared here. Right? Now, we have to check this. 8, so that's 8 squared. What is 8 squared equal to?
64.
64. Okay? And then now let's do the other side of this equation. We have a squared, which is, we'll say 5 squared plus 6 squared. Right? So we add these two numbers up. So 5 squared is 25. 6 squared is 36. What's 25 plus 36? Right? What is that?
20 plus 30, 61.
61. So this side added up to 61. It should have added up to 64. Since it doesn't equal that, we know it's not a right triangle. Not a right triangle. Okay?
Wait, but aren't the legs always meeting at the 90 degrees?
They always meet. Whether or not the angle they meet at is 90 degrees or maybe 89 or 71, that's the question. If it meet at 90 degrees, then it's a right triangle.
So
Right.
you figure out if they're meeting at 90 degrees by doing that math?
Yeah, doing that math. And if it equals, if the left side equals the right side, that means it holds, the equation holds, because the equation only holds for 90 degrees. Not if it's 91, not if it's 89. All right? Let's take a 20-minute break here, then we'll get into the homework. All right?